Hello, everyone.
Hello!
Woo! Woo! So my name is Noam.
My name is Tzook. We are brothers. We are working in MyHeritage. In MyHeritage, we work in a components infrastructure, which means that each feature that we develop by components. For example, it might be a tooltip, it might be a collapse component, and then we compose it and we reuse it in other places.
So who here also work with components, build their app with components? Can you raise your hand? Thank you. So good job.
Me too.
Yeah, you just said so.
Yeah.
So as Tzook said, we too. And what we want to talk with you about is some challenges that we in MyHeritage encountered while using components, and how we decided that it was our best way to solve them. And maybe you can take some of this, and it will help you as well. So this is our component application.
Yeah, it looks like what we're using.
Yeah, let's say we have one problematic component. It happens to all of us, right? You try to integrate a component in your tree, or either you created a component and you find out it's not that good. Maybe the props are too limited, or maybe the performance is not that good, make the app flickering.
Yeah, no, there was this tooltip component that I wanted to use, and my uncle wrote it, but it was so hard to use. It only had one prop, data. What is data? What do I need to use? Like, I couldn't use it. I wrote my own. And then we end up with like 5 components.
Yeah. So this happens a lot when a developer finds out a component that it cannot use. It will just create a new one or even not use it. And you get to a point where you have 5 components, as Tzook said, for one thing. Kind of waste of your time, hard to find what you want. So there's some sort of radius of impact when you have a bad component. It makes the other component around it, when you use it in a tree, to have to do adjustment. If you have a very limiting props or limited and very strict structure, so it also makes all the component around it need to adjust to it and try to pre-process the data, or try to use different stuff to use this component.
Exactly. If we wanted to use the tooltip component that we just talked about, we would have to make the component that uses it, we would have to create a data object and then pass it somehow. And the children that we want to pass to it will also have to be affected.
Yeah. And also the performance problem, which will just spoil your whole tree. It can happen either by one component that's really bad and make the page flicker in a certain situation. Maybe not the one that the person made it saw it, but when you use it, this is what will happen. And sometimes when you use a component a lot of times, like use a tooltip 500 times in a page, maybe there'll be a performance stall.
The page will flicker. You'll see a lot of blinking.
Yeah. And again, the whole problem is reusability. You have a problem with a component, no one will use it. You want to maximize your component reusability.
So we are going to go over the issues that we saw, and we are going to see how to solve them.
Yeah. Let's start with tabs. Tabs is the story of the presentation. We're going to build tabs, and we'll show you how we would have built tabs and what may be the pitfalls when you build it that will make other people not use this component.
Yeah, you can see that each tab is basically, you have the header and you have the content. When you click on one header, it changes the content.
So stop for a minute to think, how would you have built tabs? It could be in Angular, in Vue, in React, Slim.js, whatever you want. Just try for a moment to think how you have built it. We'll start by saying HTML did it right? You never heard someone say, hey, I can't use inputs, it's too limited, or hey, select is bad, it's not what I want, the performance is bad, right? You usually prefer to use the HTML native. Maybe they don't look as you want, but usually by reusability and the structure of them and the clarity of them, you prefer to use them.
Well,
so if you look,
except iframes.
Except iframes. So if you look on unordered list, you can see it's very declarative, easy to understand. You can understand what are the children. If you want to change the list item to ordered list, you'll have a different effect on the browser. You can easily understand what is happening.
You can put anything you want inside the list item. It's very declarative.
Yeah. If you also look on select, we start to see data management, how we manage the inner data of the component. You can use the value attribute to decide which select is active, and to decide which one you press will make the active one.
Yeah, we don't have to attach an event listener or anything. The select does everything for us.
Exactly. And we have puppies in HTML.
Yeah,
I don't know if you want it. It's in the new spec. OK, so this is how we'll implement the tabs component as to what we've just seen. We'll try to take what we saw from the list item and the select, and instead of just doing a wrapper to the tabs and pass everything by a data attribute or something like that, we'll create children that are tab component, like an item, like a list item, and they'll have the value as the one that is selected. You can change the value by changing the banana value in the wrapper. And we'll also have the header, which decide which is the header of this tab, and the children of the tab will be the actual content that we'll decide. Simple as that. But this makes you wonder, how do you decide which tab is active now?
Yeah, when you click on one tab, it becomes active. But I saw that in the tabs element itself, you can also tell it which one is active. So I can both tell it which one is active ahead of time, or it can be by clicking. So how do you tell it?
So let's talk about data management. We have two options, one called controlled, one is called uncontrolled. We'll start by the uncontrolled one. Uncontrolled it means that the component manages the data itself.
If you take a look at input, you don't have to tell anything to input, right? You just put the input element, and then user can start typing, and then you have the value on the input. You don't have to do anything else. It's easy.
Yeah, and if you want to access this value, you have to do it by querying the DOM and getting the element value. You cannot access it from the outside. It's easy or something like that. What it's good for, it's easy to use. It's simple to read and understand. Yeah. Not much to say here. Very little amount of code to get a lot of functionality. The other option is called control. It means that the parent manages the data.
If you take a look at input, you can actually tell the initial value of the input. And each time you change this, the input value will also change. And you can say, OK, when the input changed, let me know what happened. I'll handle the value. The input doesn't need to do anything. I'll do everything from outside.
Mm-hmm. Exactly. And what good is that it makes you full control from the outside. If you use components, it's easy to compose, to be used in a different component. And you can make advanced usages, such as filtering, sorting, do a lot of stuff from the outside that maybe the component's author from the beginning didn't think about. And you can now add. I want to point out that the example here is in React, but it doesn't mean it's only for React. You can use it either in Angular or Vue. Yeah. It's just very simple in React.
Yeah, we want to emphasize that we are showing concepts. They are valid also for Vue.js, Angular, React. We're showing the concepts and not a specific implementation. We're just demonstrating.
Let's dive to the code and see how it's written. We'll show first example with React, then example with Vue. They're very similar. In the end, you'll have the presentation, so you'll have access to this code. You'll have a link that you can see if you want to dive more into it and understand how it works. For making the React component of the uncontrolled version, we first start with a constructor. We define the state as an empty string. We implement the render function, which all it does, takes all the tabs and separates it to header and content. And we just use the value, as we've seen in the beginning, to decide which one is active. We'll see it in a moment in the function is selected. So we can see both, we have the get header, and they is selected to find the tabs. You can see here that the get header is using the is selected also to decide which one is active. And when you click on a header, it will change the state to be that header. OK?
Basically, the is selected is the one that says, OK, once I click on the tab, everything is done for me, and the tab serves its value on its own, and it decides from inside what should be the current tab.
Yeah. So this makes the component fully uncontrolled. I have no access from the outside, maybe by ref, so I can query the component and change its value. exactly as we've seen with input.
Okay, so uncontrolled, everything is done from the inside. We don't decide it. The parent doesn't do anything.
Example with view, very similar. We initialize the data with an empty string. We'll also render. I used a render function because it's much easier to separate the slots with render function. So you can see the slots. If you don't know Vue, it's the same as children in React or transclude in Angular. And we just do the same thing. We use a get header. We use the isSelected function to decide which one is selected. And again, the isSelected just check the tab value versus the inner state of the component.
Yeah, but we saw that uncontrolled, we don't have any chance to change anything from the outside. What if I want to control the component as a parent?
Yeah, exactly. So uncontrolled is, as we said, easy to use. But what if we want advanced usages, want to compose it, we want to do something a bit more hard, then we'll have to do it controlled. And to do that, all we have to change in our implementation is actually one line. We'll change the isSelected to be, instead of the state, to be against the props. So instead of checking the state of the component, the inner component, we'll check the props that was provided from the parent.
Yeah, this means that the tabs component, it doesn't check the inner value of the tabs. It checks the value that was passed as a property, as an argument.
And same with view. We just need to define the prop in view. It is a props. And we also can check against the parent prop.
OK, but we took a look at input, right? Input had two variants. It was both uncontrolled, that it handles everything on its own, and it was also controlled.
Exactly. So why can't we have both?
I want
right?
both. Yeah.
That will be pretty useful to have both. Because maybe someone created a component as an uncontrolled version, and now you cannot use it controlled. Maybe someone used it controlled, and now you want to use it uncontrolled, that you're tied to the logic that you need to implement in your component, and you don't want it. So being able to do both will give us maximum reusability for that component. So how do we do that? It's called controllable. I want just to emphasize it means that it's both controlled and uncontrolled, and you can change on runtime. You don't have to choose on the start of when you make the component. You can change in runtime. At one part of the run, you can have it controlled, and the other part can have it uncontrolled, and vice versa. By the way, this is how it looks. You can both press on a header, and it will change the inner state. And you can change the value, which mimics the parent value on the bottom, and it will also change the component. By the way, this is by something called UIZoo. It's an open source library we develop in MyHeritage. You're free to use it. It's a dynamic component library in React. What you see here, it's from there, that you can try and see on a component how it looks.
Yeah, it's like live coding, basically.
Yeah, it's very nice. You should check it out.
Yeah.
So how will we implement the controllable? Is very simple. We start with the uncontrolled version. And all we have to do in React is implement a component we receive props hook. What it does, it checks that the next value, the next prop value, is different from the current prop value, and then it will change the state. So we started with the uncontrolled. We have the component manage its own state. And all we have to do, we take, when the props are changing, the parent decided he wants to control it, he can do that, and it will change the inner state of the component.
It means that if we have the tabs, then the tabs handles their own. When you click on a tab header, it changes the content on its own. But if I, as the parent, when I use the tabs, if I want to force the tabs to use a different value, I just pass it. And because it's controllable, it will use that.
Exactly. And in Vue, it's actually simpler. All you have to do is implement a watch on this prop. And when it does, you change the state. That is all.
Yeah, again, this is just a demonstration of implementation. We are showing the concepts.
Yeah. So as you've seen, we have it both in React and Vue to show you that it's a concept. It's not tightly coupled to React or Vue or anything. It was hard to use. Not anymore. Not anymore. Woo! So we had a component that someone built. It was uncontrolled. We want it as a controlled. We can just implement what you have seen, and we have it both ways. It's not break and change. It works the same as before.
Yeah.
Easy to use.
It makes using components much easier. I want to add animations. Let's add something spicy for our component.
Yeah. So for everyone, it happens that you get to a point, you say, OK, I finished building my component. I want to add some animation, some spice to the component, make it look a bit smoother. And maybe you'll do something like that. You'll decide for the tabs to make a slide animation.
Yeah, I just want the tabs. When I click on one tab, it moves. It's like slides the tab to the right, and the other slide enters.
Yeah. So make it a bit nice, crispy. We'll do a transition to the left. Yeah. We'll decide a class on the left tab and on the right tab. And the active one will just do left of 0. And it will just move, right?
Yeah, we did it 1,000 times.
Someone see a problem here? Seem OK, right?
OK.
But actually, I implemented it.
Yeah, I saw it on my phone, and it doesn't look smooth.
And it's not a problem in the presentation. It's not smooth, OK? And it's no problem in the GIF.
This is how it looks.
This is how it looks.
Like in Chrome, it might look good, but if you take a mobile phone and it's has much less CPU, you suddenly see that it's not smooth. It looks bad, actually.
And I want to emphasize this will happen, it will multiply if you may use this component a lot of times and do the same animation at the same time.
Yeah, let's see why it happens.
Let's try to understand why it happens.
OK.
For that, we need to understand a bit about the browser rendering, how it works, to understand how we can manage this and fix it. Yeah. So first, this is from the Chrome DevTools documentation. We first process the JavaScript and the style. And then we do something that is called layout. Layout takes all the elements and measure their dimensions and try to understand what to put where.
Yeah, this is the step that all the widths are calculated, the heights, the margins, paddings, anything that changes where elements are sitting.
The second step called paint. Paint is when we put colors to the screen. We decide which element need to be with which color.
Yeah, and it's just like Photoshop. It sets the screen to layers, so it paints each layer on its own. And then, just like Photoshop, we have layers that we can work with.
And then the last step, called composite, you take all those layers that Tzook just said, put them together, and print them to the screen. But when you change something at runtime, like we did with the left attribute, you trigger a reflow. You trigger the layout to be processed again. And what you trigger on the three between layout, paint, composite depends on what you just changed.
Yeah.
So if you change something in the layout that need to decide all the dimensions again, you will also need to do a repaint and composition again. And if you only change the composite, you will only do that.
Yeah, it means that if, for example, we take an element and we add some margin to it, it means that the entire calculation of the geometries have moved. So we have to recalculate the layout and then recalculate the paint because elements moved, so we have to repaint them. But if we only change opacity, for example, we don't have to check locations. It's the same place. It's the same place.
We can prefer style based on triggers. You can see which triggers are available to you and what triggers what in a site called CSS triggers.
Yeah. For example, in that we can see that we don't want to use left because left moves the element and triggers layout, but we can see that actually if we use transform, it only triggers composite.
So first we'll fix the animation. We'll change the left to transform. In this example, it's very easy. We just change it to transform. And instead of left minus 100, we'll change it to translate x minus 100 and to the rest. So this is what we get. And the animation, crisp.
Whoa. But let's actually look at data. It's more interesting.
We measured it in the DevTools performance tab, and we checked how much time is going for rendering and painting. And you can see when you do it on left, it takes a lot of the time of processing time for 5 seconds. It takes a lot of time to do only the rendering and painting.
Yeah,
and
because every time it moves something, it has to recalculate it because the element actually moved.
And if you look on transform, you can see it doesn't do much because it only do the composite. It basically only do like 250 milliseconds of almost nothing.
Yeah, it's much smoother. Yeah.
So we had a performance problem with animation of one component. Maybe it makes us have a problem with a couple of components.
No more.
No more.
Woo!
Thank you.
But let's say that I have 500 animations for it.
Yeah.
Like, let's have, I have an element with 500 elements of it. Is it problematic? Let's take a look. Okay.
Let's take a look. Let's
so
say you add DOM manipulations.
Yeah. Okay. So I want to have a square tab. Okay, we have a tab that we said, and I want to make it square.
Okay, that sounds reasonable. I'll implement this code. This is in React, but it's very similar in all frameworks. I'll change the height based on the client width of the element. That's all I'll do. Very simple.
So we do one read to the DOM, we take the width, and then we do a write. We set the width, the height.
Anyone see a problem here? I don't think so.
Yeah, it's not a problem.
But when you try it, it actually takes, for 500 components, it actually takes almost 1 second to render.
Yeah,
so when you lose it in a page, there will be a lag in the page.
Yeah, it looks bad. It's not what I wanted.
Yeah, you change anything, you change anything in the layout, there will be a lag. So why does it happen?
Yeah, like the component looked fine. Why would it be so slow?
For that, we need to understand something called layout trashing. Layout trashing happens when we steal too much frames instead of using a 60 frames per second. When you use 60 frames per second, it will look smooth. But the more you do in one frame, the browser will try to fix it and give you more frames to do your processing.
Yeah, so each frame is taking more than 30 milliseconds. It's taking 20, maybe 40, maybe even 100 milliseconds.
Yeah, and you get to a point where you get your animation or your rendering happening in only 10 frames for a second, which doesn't look that good.
Yeah, it doesn't look smooth.
And when you do a lot of writing and then reading, you're forcing the browser to do a reflow for you, a full reflow. It depends on the change that you did based on the triggers we just showed you.
Yeah.
But if you change something like left, or in this case, we change the height, which causes a reflow, you just do read and write one after the other, and it makes the browser think you need this the most updated data about this width, that it will do a full reflow again. And we just make the processing a lot longer and takes a lot longer than 1 frame.
Yeah, so basically because we want the data for the square tab, we want it on demand, the frame becomes longer. But we saw it's doing the read and then the write. It's not doing the write and then the read, so it doesn't have to recalculate anything. So what's the issue?
So as we can see here, we do a read, and then we do a write, but we do that 500 times because we have 500 components. It means that this happens 500 times, one after the other. We do a read, we do a write, we do a read, we do a write, 500 times, 500 reflows.
Yeah, it
for
means
nothing.
That,
there's no much reason to do it.
The DOM has been calculated, and then it needs to be recalculated and recalculated and recalculated because we changed it, and then we read it. We wrote, and then we read.
As you said.
So
exactly.
How do we fix it now that we know the issue?
So how can we fix it? Not that hard, actually. You know request animation frame? Everyone know request animation frame?
OK, so request animation frame is a native browser function that actually has been for a while, and it takes the frames that we have and calls the function that we give in the next frame.
So this actually delays the time that the function will happen, the read will happen, only to the start of the next frame. It makes sure that we'll not reflow, and all our reads will happen together in the next frame. But how do we make sure we don't do a write just after the read? We'll use a set timeout to delay it even more, that all the writes will happen afterwards. So we have all the reads happening in the next frame, in the request animation frame, and all the writes happening after all the reads were finished.
OK, this means that we have 500 tabs for what we have said. And each tab on its own, it does the read. It checks the width of its own. But they're all doing it together, one after the other. And nobody wrote anything, so it's all fine. And then after they all finished, they all do the timeout. And because it's async, it's doing the writing afterwards. So it's doing all the reads together and all the writes at the end. And this makes one frame much, much faster.
So as you can see here, if you try to use it, it only takes 45 milliseconds.
It's like 20 times faster.
It's a lot faster. It's something that you can actually use. So people in your company or in your organization will use this component because it's okay to use even 500 times.
Yeah, it's not like a component that you put and then your app freezes and you say, okay, I'm not going to use it.
We had a performance problem. No more.
Not anymore. Okay, let's recap what we've gone through.
Let's recap everything we've seen. So first, let's make our components declarative. Learn from HTML. They did it right. They know it exists for a long time for a good reason. We should try to understand what's good in it and take it when we are building our components.
Yeah, it's like the declarativity when you put unordered list UL and then you put inside the list item. The person that is going to use it is going to understand what you wanted.
Secondly, we saw the controllable pattern that make your component both uncontrolled and controlled. Those stuff are very powerful when you understand them, and you understand the data flow of your component a lot better.
It's just like input. When you look at it, you can both control it, which means that, okay, input body, I'm going to give you the value, and let me know on change when something happens. And you can also say, okay, input, you're on freestyle, just whatever is typed, just save it in your value, and it does it on its own.
Animate wisely. Try to trigger composition or pate instead of free flow.
Yeah, we saw that there's CSSTriggers.com, and it tells us which CSS change does what. So we know to use transforms, for example, over left, over margins, for example.
Don't layout rush. Understand your browser, understand what it does when animations are happening.
Yeah, when we have one component and it's doing read and write, we might think it's fine. But we need to think in scale because we are in the components world. And one component might spoil the tree because it's used many times. And nobody will use it because in combination it doesn't work well. So make sure that you think about the usages of the components.
And make components reusable. Don't spoil your component tree, as Tzook said.
Yeah.
By the way, use UI too. So thanks you for listening. Okay. The presentation is available in this URL. Will be at the MyHeritage booth if you have any questions.
This is the time to take your cameras and take a screenshot of this because you'll want to look at the slides later. These tips are very good. They made our development much faster and much better. And we reuse our components, actually. It's cool.
Thank you very much.